Hello, and welcome to this video about parabolas. In this video, you will learn how to get the equation of a parabola into standard form, and how to identify the vertex, focus, directrix, and axis of symmetry of a parabola. A parabola is one of the conic sections. Conic sections are the figures formed when a cone, or in the case of a hyperbola, a double cone, is cut by a plane. If the plane is perpendicular to the vertical axis of the cone, a circle is formed. If we tilt the plane a little further, and again slice the cone, we'll end up with an ellipse. If the plane is parallel to one of the edges of the cone, we'll end up getting a parabola. The closer we move the plane to the edge of the parabola, the steeper the parabola will appear. And finally, if we rotate the plane so that it's parallel to the vertical axis of the cone, we get the two branches of a hyperbola. So once again, parabolas are the conic section formed when a cone is cut by a plane parallel to an edge. Locus definitions. The locus of points equidistant from a fixed point is a circle. So every point on the circle P is the same distance from C, the center of the circle. Here's another one. The locus of points equidistant from a given line, the yellow line, are two parallel lines, one on either side. So in this case, both P and P prime are always the same distance from the given yellow line. Well, a parabola is the set of points, in this case they're going to be A, equidistant from a fixed point called the focus, located at C, and a given line called the directrix, located towards the bottom of the screen here in gray. B will always be a point on the directrix as close to A as possible. In other words, if we dropped a perpendicular from A to the directrix, that's where B would be located. As we set the points into motion, you can see that A maintains the same distance from C as it does from the given line, the directrix. When A, B, and C line up vertically, so that the 3 points are collinear, A is now at the vertex. Once we go past that point, we're past the axis of symmetry, and now the green and the blue lines start to grow once again. And again, the green line and the blue line are always equal in length. What I would like to show you is what happens when I move the focus closer to the directrix. So let's say we locate the focus here. We'll still end up with a parabola. But how is my parabola going to change? Well, in order to see that, let's change the color. Let's go with a nice purple color. And now let's see the locus of points. Once again, A is always the same distance from C as it is from B. And you can see I once again get a parabolic shape, but this time my parabola is steeper. The purple parabola is steeper than the original red parabola. So if I move the focus closer to the directrix, we get a steeper parabola. If I move the focus further from the directrix, the parabola is not as steep. It's flatter, if you will. And one last visualization. Here I have a parabola in purple and a point P on the parabola. F is my focus. D is a point on the directrix, such that a line drawn perpendicular from P to the directrix will intersect at D. And my blue point at V is my vertex. You can see P is the same distance from F as it is from D. Even as I move P, the distances change, the lengths change, but they're constantly equal to each other. The smallest the distances will be when the point is right on top of the vertex. After that, the lengths once again start to grow. So, a parabola is the set of points equidistant from a fixed point called the focus and a given line called the directrix. That is the locus definition for a parabola. Here I have a diagram of a parabola. We've located the focus at h comma k plus p, and the directrix at y equals k minus p. If we draw a perpendicular line segment from the focus to the directrix and find the midpoint of that line segment, will be located at the vertex. The vertex would naturally be h comma k, because it would be p units below the focus and p units above the directrix. Of course, if p is negative, this whole picture flips upside down. Now let's look at a general point on the parabola x comma y. xy needs to be the same distance from the focus, h comma k plus p, as xy is from the directrix, y equals k minus p. In order to find the distance x comma y is from h comma k plus p, we'll have to use the distance formula, which is what we've done to the left-hand side of this equation. To find the distance x comma y is to the directrix, we would subtract the y coordinates, so y minus the quantity, k minus p. If I square both sides, I'll get rid of the square root on the left-hand side, but we'll pick up a square on the right-hand side. Next, I would like to distribute the negative sign so that my trinomial is now simply y minus k minus p on the left-hand side, and I have a trinomial y minus k plus p on the right-hand side. Each trinomial needs to be squared. I would encourage you to try to do this. If you multiply out the trinomial y minus k minus p, you will get these 9 terms in blue. Likewise, on the right-hand side, if you multiply out y minus k plus p, you'll get these 9 terms in green. I am not going to multiply out the x minus h quantity squared. That's part of the standard form, as you'll see shortly. You'll notice several terms on either side of this equation that are the same, so therefore they can cancel out. Specifically, 5 terms on the left-hand side will cancel 5 terms on the right-hand side. We can then combine the like terms. So I have a minus py here and another minus py here, so that makes it minus 2py. I have a kp here and another kp here, so I get 2kp. I've done the same on the right-hand side. This minus 2py and this positive 2py do not cancel. Instead, if I add 2py to both sides and subtract a 2kp from either side, we end up getting x minus h quantity squared equals 4py minus 4kp. On the right-hand side, I can now factor out a 4p. And once I do that, I have the standard form for a parabola. That is x minus h quantity squared equals 4p times quantity y minus k. The vertex from our picture, recall, was h comma k. The focus was located at h comma k plus p. The directrix is y equals k minus p. The axis of symmetry is the imaginary line that would run between the vertex and the focus. It provides a mirror image on either side of the line in the parabola. Since both the vertex and focus have the x-coordinate h, the axis of symmetry is the equation x equals h. And finally, the parabola opens upward if p is greater than 0, which puts the focus above the vertex. Incidentally, parabolas will always open up around the focus and away from the directrix. And it opens down if p is less than 0, because k plus p would be k plus a negative, which would put the focus below the vertex. So let's look at this example. Suppose we had the equation of we want to find the equation of a parabola whose directrix is y equals negative 2 and whose focus is located at 3 comma negative 8. Well, recall that the formula for a parabola, or the equation of a parabola in standard form, is x minus h quantity squared equals 4p times the quantity y minus k. Since we are given the focus as 3 negative 8, and the focus we know is h comma k plus p, h must equal 3 and k plus p must equal negative 8. The directrix we know is y equals k minus p, but from the information we are given, we know that the directrix is y equals negative 2. So it must be that k minus p equals negative 2. Now if I add the two red equations together, the p's will cancel and I'll get 2k equals negative 10. And if I divide off the 2, k would equal negative 5. I then take the negative 5 and I could substitute into either red equation. I'm going to choose the top one. K plus p equals negative 8. When I replace k with negative 5, I get negative 5 plus p equals negative 8. If I add the 5 over to the right-hand side, I get p equals negative 3. All that's left to do is to come up here to the standard form for the equation of a parabola and replace the values of h, k, and p. So I will end up with x minus 3 quantity squared equals 4p, 4 times negative 3 is negative 12, times y minus negative 5, so in other words y plus 5. Here's a similar example. Say we want to find the equation of an upward opening parabola that passes through the point 5, 12 with the vertex located at 1, 4. Once again, a reminder to the standard form for the equation of a parabola. We know that the vertex is located at h, k. Since we are given the vertex, we know h is 1 and k is 4. If we substitute those values in to our standard form, we end up with x minus 1 quantity squared equals 4p times quantity y minus k, or y minus 4, which you'll see here in dark blue. We temporarily substitute in the point. 5 goes in for x, 12 goes in for y. We know that that will result in a balanced equation. 5 minus 1 quantity squared is 16. 4p times 12 minus 4 is 32p. If we divide each side by 32, p equals a half. Now we're all set to write the equation of the parabola. X minus 1 quantity squared equals 4p, 4 times a half would be 2, times quantity y minus k, or y minus 4. This time we're given the equation of the parabola, x plus 6 quantity squared equals 8 times quantity y minus 3, and we're asked to find the coordinates of the focus and the equation of the directrix. Well, lining up the given equation with our standard form for a parabola, we can see that x plus 6 quantity squared is the x minus h quantity squared. That means h must be negative 6. X minus negative 6 would produce the x plus 6. Y minus 3 corresponds to y minus k, so k must equal 3. And 4p corresponds to the 8, and if we divide either side by 4, we get the result p equals 2. So our focus, which we know is at h, k plus p, would be negative 6, 3 plus 2, or 5. And the directrix is the equation y equals k minus p. So that would be y equals 3 minus 2, which would be y equals 1. Now we come to the part about completing the square. Here I've taken 8 binomials and FOILed them out and wrote the results. You'll notice each time that the red number, the coefficient in front of x to the first, is twice the value of the blue number, or the second term inside the binomial. You'll also notice that the green number is the blue number squared. Negative 1 squared is positive 1, negative 2 squared is positive 4, and so on. Even over here on this side, the same holds true when we switch it to addition. X plus 1 quantity squared is x squared plus 2x plus 1. The red number, the coefficient of x to the first, is twice the second term in the binomial. And the green number is the second term of the binomial squared. So if we look at this last one, x plus 4 quantity squared would equal x squared plus 8x plus 16. 8 is twice the value of 4, and 16 is the result when 4 is squared. Towards the bottom of my screen, I have some unfinished perfect squares, which gets to the process of completing the square. Since the red number is twice the blue number, I know I need to cut the red number in half in order to get the blue number. Half of negative 10 is negative 5. When I square the negative 5, I'll get the green number. Negative 5 quantity squared is 25. So, If this were x squared minus 10x plus 25, it could be rewritten as x minus 5 quantity squared. Over here, nearly the same thing. Half of 10 is 5. 5 squared is 25. So x squared plus 10x plus 25 is x plus 5 quantity squared. The reason why we need to know how to complete the square is because if we were given the equation of a parabola in this form, 2y equals x squared minus 8x plus 2, and we were interested in putting it into standard form so that we could pick out the focus and the directrix, etc., we would need to complete the square. So the first thing I'm going to do is take the constant term and move it away from the x's. I'm going to move it to the side with the y. So I'll subtract 2 from either side of this equation. That will leave the result 2y minus 2 equals x squared minus 8x. Then I'll take half of negative 8, the coefficient of x to the first, square it. Half of negative 8 is negative 4, squared is positive 16, and I'll have to add that to each side of the equation to keep the equation balanced. Negative 2 plus 16 is 14. X squared minus 8x plus 16 is x minus 4 quantity squared. Then we factor out whatever number is in front of y, so the coefficient of y. So on the left-hand side, I'm going to factor out a 2, and that leaves the quantity y plus 7, which now we're really into the standard form. X minus 4 quantity squared equals 2 times the quantity y plus 7, and that matches up to our standard form. So, to recap, a parabola is the set of points equidistant from a fixed point called the focus and a given line called the directrix. The standard form for the equation of a parabola is x minus h quantity squared equals 4p times quantity y minus k. The vertex is located at h comma k. The focus is located at h comma k plus p. The directrix has the equation y equals k minus p, and the axis of symmetry is x equals h. Finally, the parabola opens upward when p is positive, and it opens downward when p is negative. And that's my video about parabolas. I'm Murray Wright. Thanks for watching.